Hello class 11. As mentioned earlier during the Google Meet class, of course, this video is about integration. Okay, a very important part of mathematics, a very important part of calculus. Okay, now let me give you an overview. Let's start with the overview. The symbol that we use in integration is this. It's like an elongated S. It's like you have an S and you stretch it longitudinally. Okay, so that you get an elongated S kind of a thing. This symbol is called the integral sign. It's called the integral sign. Now, integration basically means summing things up. Okay, accumulating things. Alright, integration basically means that. But what we are basically accumulating, or what we are basically summing up, alright, let us give a look into that. Okay, so alright, so this is the symbol for integration and this is how you write. If you do not have anything written over here down below the integral sign or above the integral sign like this, okay, if you do not have anything like written, then that is called indefinite integration. Now in physics we do not basically use indefinite integration, and in mathematics when you start learning integration you start with indefinite integration. But in physics, we do not use indefinite integration much. What we use is something called definite integration, which is the case when you have values or constants. Okay, these are basically constants. x1, x2 are basically constant values. So when you have values or constant written below the integral sign and above the integral sign like this, then the integration is called definite integration. And these values x1, x2 are called the limits of integration. So these are the limits of integration. So mind you, if you do not have the limits of integration, then that is indefinite integration that is. And when you have limits of integration, that is called definite integration. And in physics, we need definite integration. Now what does this mean? What is this? Integration, okay, you read this as integration of f of x simply. Okay, so from x1 to x2, integration of f of x from x1 to x2, this is how you read this. Now what is this thing basically giving us? This definite integration gives us the area under the curve. Now what is that? Let us give a look into that. So we have this graph, we have this plot, okay, and we have x along the, of course, x-axis. Okay, so this is the independent quantity, and we have a function of x. So to say, this thing is dependent on x. Function of x meaning this thing is dependent on x as the value of x changes. This thing also. Now this function of x is a certain curve. As x changes, this f of x changes this way. As you can see, it slightly goes on increasing as the value of x changes. Now what is integration of f of x from x1 to x2 giving us? It is giving us this area under this curve. So the area under this curve, okay, this area is what is integration of f of x, okay, and we are summing up from the value of x, which is x1, to another value of x, which is x2. X itself is a variable, it is the independent quantity. So we've started from x1 to x2. So this is what it means. Okay, we've started from x1 to x2. We are measuring the area from x1 to x2, or rather, we are measuring the area in between x1 and x2. Okay, so that is what it means. Alright. So definite integration, mind you, it gives the area under the curve from x1 to x2. When x is changing from x1 to x2, so that area you are finding. Now, what is f of x into dx? Let us look into that. Now, f of x is this certain function you can see. Okay, it is dependent on x, of course. Now, what we do is, this is the area in between x1 and x2. This is the area under the curve in between x1 and x2, of course. But what we now do is, we divide this difference. We divide this difference, x2 minus x1, so to say, this difference, okay, this value of x, so to say, into very small strips. Very small strips. Such that every distance is equal. This value of x okay, every interval, so to say, along the x-axis has the same value. And let us say this same value, this small value is d of x. Okay, d of x is what? It is a small change in x. Alright, so what is f of x into dx? So where do I write? So what is f of x into dx? F of x into dx is the area of the small, so to say, almost rectangular strip. Okay, f of x into dx, every interval is dx, remember, okay, and we are going on dividing it into small dx's along the, so dx, another dx, another dx, another dx, another dx, these are all dx's, okay, small dx's. So f of x into dx gives us the area under, or area of this small strip. So another f of x into dx will be this strip. Alright, now what is therefore the total area? The total area is a summation, so to say, of this f of x into dx. That is, the total area is the sum of small areas, the area of these small strips. Okay, every strip has its own area. So when we sum up the area of each of these small strips, what we get is, we get the area under, we get the whole area, so to say, under this curve. So we get this whole area. If we divide this strip into a infinite number of strips, so to say, infinite number of strips, of course, which I can't draw or show you here in this picture. So if we divide the value of x into infinite small values, so to say, the area under the curve or the rectangular strip goes on decreasing, infinite number of rectangular strips like this we have. Okay, infinite number. Then this summation is represented by this sign, the integral sign. Okay, and we write this as f of x dx. So to say, we are summing up. So here comes the word summing up. So integration means we are summing up the area. We are summing up small fx dx. Fx into dx is, like I've already told, the area of the small strip. So the sum of each of these fx dx, fx dx, fx dx, okay, together, all of these different fx dx is going to give us the area under this curve. That summation, that adding up of the small areas of the rectangular strip is mathematically represented by this. Okay, and in here we are adding up from which value of x to which other value? We are adding up from the value of x which is equal to x1 to the value of x which is equal to x2. So integration of f of x from x1 to x2 therefore gives us the total area under this curve. Okay, of course, the boundary or limits is from x1 to x2. This is the limit, so to say, limiting condition, and therefore these are also called the limits of integration. Okay, we are not going beyond x2 and we are not coming below x1 also. We are not interested in whatever is happening beyond x1 and x2. We are only interested in between x1 and x2. So therefore x1, x2, it's called the limit of. Now x could be your time, x could be time, and f of x, the function of time, could be speed. So you could be plotting speed versus time. Alright, so this is the speed of a car as time progresses, and you can see the speed of the car as time progresses is gradually going on increasing. Alright, so what is f of x into dx, so to say? F of x is speed and x is time, so to say. So dx, a small change in time, dx is small change in time. So f of x into dx is basically giving us what? It is giving us speed into a small change in time. So speed into time is what? Distance. If you are plotting speed along the y-axis and time along the x-axis, then speed into time, that is fx into dx, is giving us this area of the small strip, so to say, is giving you what? It is giving you the distance traveled. And integration from this value of x1 or this value of time to this value of time of f of x, okay, is giving us this total distance traveled from time t1 to time t2. Likewise, f of x could be what? F of x could be force. F of x could be force. And along the x-axis, you could be plotting displacement. X could be a displacement, so to say. Alright, so force into displacement, f of x into dx would be what? It is force into displacement basically. So force into displacement is what? It is work done. Alright, so the area under this curve, so to say, from x1 to x2 is giving us what? It's giving us the work done. The area under the curve is basically giving us work done. So this is a very brief overview of integration, remember, or most precisely, definite integration. Now there is one formula from integration. There actually are, lots of formulae from integration that you need to learn when you actually do integration. But here I am today interested only in one formula that I would like you all to remember, because this formula we very often use in physics, and the formula is this: integration of x to the power n, okay, dx is equal to, this will be x to the power n plus 1 divided by n plus 1. This is the formula, remember. Okay, integration of x to the power n dx is x to the power n plus 1 divided by n plus 1. This is what I would like you all to remember. And let me also tell you how to solve the limits of integration. Say you have limits of integration, the value of x, say we are integrating from 1 to 2. X could be anything, take it to be anything, alright? So let me erase this. From 1 to 2. So how do we solve this is, first of all, you do not worry about the limits of integration, you only care about the integration, the formula. Integration of x to the power n dx is x to the power n plus 1 divided by n plus 1. And then after, what you do is, you put a bracket like this. And then after, this is called the upper limit, this is called the lower limit. So you write the limits of integration this way. Then after this becomes, what you do is, like I've already told, these are what the limits of integration, these are the values of the variable x. So what you do is, first of all, you substitute the upper value of x. So upper value is 2, so this will be 2 n plus 1, whatever n be, okay, divided by n plus 1. So we've substituted the upper value of x. Then after, what you do is you substitute the lower value of x. But then after, what you do is you find the difference between the two. So substitute the lower value, so 1 to the power n plus 1 divided by n plus 1, and you find the difference between the two. Now if n is given, you can easily calculate this. So this is how you solve for integration, or rather this is how you solve for definite integration. First of all, you substitute the value of the upper limit, then you substitute the value of the lower limit and find the difference between the two. So this is about integration. This is actually everything that we need in physics for now. Anything extra that we need, I will let you know.